In this section, we'll be looking at creating and configuring virtual machines. Once you have configured the virtualization host, the next logical step is to create the guest machines that will be hosted in your environment. These virtual machines will also require a certain amount of planning. They have a number of different components like disk, network cards, switches, memory, CPUs, storage. We're going to discuss each one of these components and the different choices you must make as you are designing and therefore configuring these virtual machines. So after we've designed and planned out the virtualization host computer, well, then it's ready to host guest virtual machines. However, there's more than just as much planning, if you will, to create and configure the virtual machines as there was for the virtualization host. With virtualization comes this ability to maximize the physical server and no longer have any unused resources. And so that's certainly a huge advantage. Multiple virtual machines are advantageous, but a lack of planning can cause less than efficient performance. It requires much more planning than the one-to-one way of thinking prior to using virtualization. So we just need to be careful in doing this. With virtualization, we have the ability to add computing resources to a virtual machine without having to purchase additional hardware. So even though that's a concept that's sometimes hard to grasp, we could consider the virtual machine as more of a portable system that you can move from one host to another when required. You can think of it as a system to which new hardware can be added on the fly. Additional virtual drives, additional NICs, additional memory, additional CPU resources, those kinds of things. Now, mind you, the guest operating system is unaware that it's running in a virtual environment, but we have this added flexibility. Let's talk about the virtual machine components that exist. This is just sort of an overview, but we'll get into each one of these specifically. The first is virtual disk. Just like a physical server, a virtual machine is going to need to have a place to install operating systems and install applications, and that is a virtual disk. It's just a file that represents a physical disk to the virtual machine. You have virtual NICs as well. These are network interface cards. They are associated with a virtual switch, which really control, what part of the network this system is connected to. But the virtual NIC, just like a physical NIC, is responsible for transferring packets to and from the operating system running on the virtual machine. Virtual switches can come in different flavors. They can be a virtual network that's connected to a physical network card, or they can be private networks for use sometimes in clustering or private VM conversation. Virtual memory, not the same thing as what that term means on a physical system. Virtual memory is just the amount of memory that is allocated to a virtual machine. And that's based on the resources that are available on the host, as we have discussed. And of course, we also have the virtual CPU. And so we discussed sizing these out, sizing the virtualization host out, but when it comes to actually creating and configuring the virtual machines, we're actually implementing this. So it's important to have thought about all of these components. Of course, when we plan out the hardware of the host, we now need to put it into practice. We have virtual storage as well. That would be the final different component of the machines. And so, as I said, this is just meant to be an overview, and we will go through each of these aspects of virtual machines. So we begin with virtual hard disk, which, just like a physical server, as we said, a virtual machine needs to have a place to put things, the operating system, the applications. And the virtual disk represents itself to the guest operating system as physical storage. The virtual disk file actually resides on the host computer, but it's seen by the guest virtual machine. And it's seen On the host computer is just a single file, but on the guest, it's seen as a regular drive would be. It contains the same properties and features of a physical drive, like your disk partitions, file system, files and folders, those kinds of things. Root folders, subfolders. But there are different choices to be made, and you need to take care and do this right. The type of disk, the name of the location of the disk, the size of the disk. Of course, every different manufacturer has different terms. So it's not as easy as just saying, okay, let's create a virtual hard disk for this virtual machine and put it here. There are some additional choices to be made. So let's take a look at some of those choices. As we said, disk types and terminology will vary based on virtualization platforms. Okay, so for example, using Hyper-V, then you have the options of making a fixed disk, a dynamically expanding disk, or a differencing disk. Okay, let's talk about those different options. A fixed disk is a disk of a particular size. So if you say that you want to create a 20 gigabyte virtual hard drive and you choose fixed disk, then the file that is created is 20 gigabytes in size. It is then operating sort of as a 20 gigabyte container. We will fill it up. But the point is that it's already registering to the host operating system that's 20 gigabytes. So it actually takes a little bit longer to create a 20 gigabyte file than it would be to create a 20 megabyte file. As you can probably imagine, fixed disk is that way. Dynamically expanding is the exact way that it sounds. It starts out small and it grows on an as-needed basis. All right, so you can say, I want to create a 20 gigabyte virtual hard drive. But if you configure it as dynamically expanding, it'll only be roughly 20 to 40 megabytes in size to begin with. And then as I add data to it, it will expand on the disk. Obviously, that gives me a lot of flexibility. Also lets me rapidly provision VMs because I can create those virtual hard disks much faster. And the final type of disk in Microsoft is referred to as a differencing disk. Now, differencing disks are very odd, and actually Microsoft's official standpoint is that you shouldn't use these in production environments, but they can be used to rapidly deploy demo environments, development environments. They do have a place. It's just not in your typical, high resource utilization VMs. What a differencing disk is it's a disk that's based off another parent disk. And so when you go to create a differencing disk, it asks you to reference a parent. Okay, what is this relationship all about? Well, essentially, and I'll give you my example of lab environments, demo, non-production, test beds, where we are going to have, 5 servers and they're all running Windows Server 2012 R2. For instance. Well, why would I install 5 operating systems? I wouldn't. Instead, I'm going to set up one virtual machine. I'm going to install Windows in it. I'm going to make sure it has the latest updates, and I may even install a couple of base roles like file and storage services. I might configure a couple of rules in the firewall, turn on remote management, etc. Once I've got that system the way that I want it, I am then going to shut it down. Okay. What we have now is we have a virtual hard disk that has the operating system already installed on it. So if I then create differencing disk and point them to that machine as the parent, we can immediately duplicate that virtual machine times 5. Okay. Only we make the parent disk read-only. So it's got the base operating system configuration, and now the new systems are booted up, and any changes that are made, they're made into the differencing disk. It's what makes it different than the other. So important to understand that, the option there. The problem is you've got a bunch of virtual machines feeding off the same virtual hard disk, and so from a performance perspective, the differencing drives that doesn't work very well. That's why we said it's really for non-production, demo environments, dev environments, those kinds of things. Okay, with VMware, if you're creating a virtual hard disk, you have the option of creating a thick or a thin disk. Just different terms. A thick disk is similar to a fixed disk in Microsoft Hyper-V, in that the size you specify is completely allocated, I should say, during the creation of the virtual disk, whereas a thin disk is similar to the dynamically expanding disk. It starts out small and it adds space as required by the different virtual machines. So, while they're using different terms to define the disk, the concepts are pretty similar. So regardless of whether you're using Hyper-V or ESXi or Zen Server, you still need to decide which type of disk you're going to use for which particular application. And as a general rule, if you are concerned about disk space, then you would use a thin disk or dynamically expanding disk. If size isn't a concern, then you would probably use a fixed disk or thick disk. Now, another concern when you're planning for virtual disk, or a concept that's critical to understand, is thin provisioning. Thin provisioning allows virtual disks to allocate and commit storage space on demand, and then use only the storage space that they currently require. So with thin provisioning, a company can create multiple virtual disks and then set the limits as greater than the total amount of currently available storage. This essentially allows you to overcommit the storage capacity. Now, obviously, in this type of situation, monitoring is going to be critical to control the actual disk usage. But if you configure it correctly, thin provisioning can save an organization time and money. All right, just keep in mind that with thin provisioning, you're not guaranteed the space, and so you have potentially a difference in performance level. And so sometimes applications will not fare well with thin provisioning. All right, SQL, Exchange, those are two database style applications that don't really work very well with thin provisioning. But the documentation for those applications will state very clearly that they don't work well with thin provisioning. We have to take all of these things into account. From a flexibility standpoint, thin provisioning and dynamically expanding disk or thin disk are the way to go. But in some cases, from a performance standpoint, I want to stick with the fixed disk configuration. I would say, just as a general rule of thumb, make sure you're understanding all aspects of your choice, all the ramifications of your choice, how it relates to the operating system and the applications, and we should be good to go. The next component we want to look at is the virtual NIC. Planning this is just as important as planning the virtual disk configuration. The network interface card in a computer is what allows the computer to interact with other systems on the network, other virtual machines, other devices. This is a virtual NIC, and a virtual network interface does not have any physical components. It's essentially a software component made up of software drivers that mimic or emulate a physical NIC. But it does allow you to change some of the properties of the NIC itself, and it still is going to require careful planning in order to prevent bottlenecks. Some of the configuration properties that you can change are the MAC address settings. It's very easy to simulate a certain media access control address on a virtual NIC. The network connections, the physical network to which this machine is connected, and the VLAN IDs. Okay, so it does allow for greater control over the virtual NIC from within the hypervisor software. But once this NIC has been configured and installed on a virtual machine, it's going to function just like a physical NIC is installed on a physical server. After you attach the virtual NIC to a virtual machine, the organization then has the ability to add that virtual NIC to a virtual network. A virtual network is simply a group of network devices that are configured to access local or external network resources. In effect, it's the network that has traffic between virtual servers. It's routed between virtual routers, virtual switches. It's often called a virtual switch on the hypervisor. Okay, so in Hyper-V, for instance, you actually go in and create and configure virtual switches. And it's during that creation that you determine whether the virtual switch is associated with a production network, an internal only, or a private network. Then when we create these virtual NICs, we're actually associating them with a switch. If I associate them with a switch that's associated with an actual network connection, then they will have a physical connection to the outside. If I associate them with a virtual switch that's internal only, they'll only be able to communicate with other VMs on that host, which is not nearly as useful. But you see the idea. The virtual NIC is then associated with a switch, aka network, that's comprised of switches and some virtual routers, and that allows them to communicate. The virtual switches do provide similar features to physical switches. They do have the ability to have multiple VLANs. They often have the ability to import a configuration from the manufacturer to make them look and feel like, say, a Cisco switch or HP switch. They're, of course, doing just frame switching based on MAC addresses, and they're providing that communication. In most cases, the virtual switch is actually functioning as like a layer 3 switch. So it's doing routing when necessary and frame switching at other times. But some of the other options that they would do would be policy enforcement, so controlling the type of traffic that is able to flow, isolation. We said we could create virtual switches that isolate VMs and allow them to communicate only with one another. Traffic shaping, so prioritizing certain types of traffic over others, as well as VLAN support, so the ability to create virtual LANs in order to create logical subnets. So the virtual switch will provide all of that, and it is important for us to understand the concepts here, the creation of the NIC and the association of it with a virtual switch, aka virtual network, which determines what systems that NIC is able to communicate with. So this is going to be a big choice on every virtual machine that you create. The next component that we want to look at is memory, and managing memory on a virtual machine is much different than managing memory on a physical server. When you're managing memory on a physical server, you got to decide at the time of purchase how much memory you need to have. When you're building or deploying a virtual machine, you can change the memory on the fly as needed. And it can be based on the configuration. It can even be set up dynamically. So therefore, managing virtual machine memory is much easier, and it allows an organization to maximize the resources for that virtual machine. We can set an initial size of virtual machine's memory, and then we can change that setting after the virtual machine has been created and operational. So I might have created a virtual machine, for instance, that was only running file and print services, and so I didn't really know the amount of memory that ultimately would be required. So I set up a minimum amount of memory, then I monitor the virtual machine to determine its memory utilization. If it gets up to 80, 90, 100% utilization, I can easily increase the amount of memory, and I don't have to purchase additional hardware. Now, of course, that's only possible if you have additional memory available on the host computer, which is why we talked about sizing out the host computer. The host computer has to have enough physical memory available. And we have to consider memory peaks when required for operating system, and application support. So, we kind of mentioned this before. I mean, dynamic memory gives us the capability of being flexible. Dynamic memory truly is not allocating a set amount of memory to a virtual machine. It is simply saying the virtual machine has this minimum and this maximum, let the host decide. It lets me run more virtual machines on the same system, but we need to carefully monitor it to make sure that the virtual machine performance isn't suffering. If you do go with fixed memory, which is still required by some applications, just make sure that you adequately plan it out so that you don't have a situation where machines can't start, okay? It's just an important thing to consider, both when sizing the host as well as when creating and configuring the virtual machines. The next component is storage virtualization. Planning where to store the virtual disk and configuration files is something that needs careful consideration. Storage virtualization is simply a concept that groups multiple network storage devices into a single storage unit that can be managed from a central console. And this can be used by the virtual machine or host computer. Storage virtualization is usually occurring within a SAN, a storage area network, and so it just simplifies the management of a more complex environment. Storage virtualization is going to provide a number of different advantages. It enables, number one, just the use of shared storage devices. It also solves the issue of a single server owning the storage and allows multiple host systems to access the same storage simultaneously. In a non-virtualized storage environment, host computers are connecting directly to storage that's either internal to the host or on an external array. The problem with that scenario is that the server is taking complete ownership of the physical storage. So the entire disk is tied to a single server, whereas virtualized storage does not do that. It allows that shared storage device. It solves that issue. Shared storage can present storage to a host computer. The host computer can then in turn present the storage to a virtual machine, and multiple host computers can access the same shared storage at the same time, which allows virtual machines to be migrated between host systems. Virtualization software will typically support all your storage interconnects, fiber channel, iSCSI, fiber channel over Ethernet, direct attached storage, and the software itself gives an interface to simplify how the virtual machines are accessing that storage. It typically will also provide different controllers, SCSI controllers and IDE controllers, so the operating system can recognize the controller. So a lot of your storage virtualization is behind the scenes, if you will, as it relates to the virtual machines. There's a final component when it comes to creating and configuring virtual machines, and that is the guest tools. These are software additions that are added to a virtual machine after the operating system has been installed. They enhance performance of the virtual machine. They also improve interaction with the host computer. They make it easier to manage the virtual machine, usually by providing enhanced features. These can include faster graphics performance, time synchronization between the host and the guest, increased network performance, file copy capabilities, that is the ability to copy files between the guest and the host directly. They're also responsible for integrating drivers into the guest virtual machine operating system. Now, the guest virtual machine OS can run without installing the guest tools, but it's going to lose a lot of important functionality. It's going to lose some ease of administration. For this reason and the reason that the installation of the guest tools is pretty easy and straightforward in your major virtualization applications, even sometimes being built into the operating system, there really is no reason for you not to install the guest operating tools. Okay, they will help the virtual machine interact with the host machine, and some VM features may not even work without the guest tools being installed. So it is an important component. It's not actually a component of the virtual machine itself, but it's a component that allows that interaction. So creating and configuring virtual machines, of course, is a big, important part of virtualization environments, and we've been able to look at the various components that comprise those virtual machines. In this section, you learned about creating and configuring virtual machines. The virtual machine hosted on the hypervisor includes a number of components. We discussed these components and how to make the correct choices in regards to them. With virtual hard disk, we discussed the different types and terminology that's based on virtualization platform, how to utilize thin provisioning to take the most advantage of the space that you have. We talked about the association between a virtual network interface card and a virtual switch, a discussion in memory, storage virtualization. All of these are extremely important when it comes to creating and configuring virtual machines so that you ensure that the virtual machines have all the resources that they need to provide whatever function it is they happen to be providing to your environment.